Hi everyone, this is part 2 of the water solubility prediction web app. At the end of part 1, we already saved the model and the standard scalar. So in this part, we are going to focus on developing the web app design, implementing the web app using Streamlit, and upload the web app files to GitHub. So we need to upload the web app files to GitHub. And lastly, we will deploy the model from GitHub to a Streamlit cloud. So we'll do this 4 steps. So now let's start with the first step. Let's start with the web app design. So at high level, at least, the user should be able to interact with the model by providing smiles representation of molecules, and the model should be able to respond by providing the water solubility of the corresponding compounds as an output. These outputs will be either displayed on the web page, or this could be either a CSV file so that the user can analyze them later. Let's go a little bit detail. The user can provide smile strings of the molecules. The web app, on the other hand, will accept these smile strings from the user and then calculates the 200 RDKit molecular descriptors that we used for the training set, if you remember. And then these descriptors will be scaled using standard scalar, and the model will use these scaled features to predict the water solubility of the compounds. And finally, the user will get solubility values. Either the values will be displayed on the web page, or they will be given as CSV files so that the user can download them and analyze the results later. So this is the idea of the web app design. Okay, now let's see the implementation. I have a folder, Aqua Solubility Web App. In this folder, I already put the model and the standard scalar, which is obtained from part 1, and also the test set. If you remember this test set of the 98 compounds, let me see what it contains. It contains the experimental values. These are the experimental values. Actual column contains the experimental values of the compounds, and this column contains the predicted solubility values. So I just want to plot the experimental versus actual values on the web page, so that's why I just put this CSV file on the folder. Okay, there's also a text file here. This is a requirements file. I'll show you how to generate this one. So we need this one to deploy the model to the Streamlit cloud. Another important file that we have is the Python file. Okay, this file written in Streamlit. Let me double click this one and see what it contains. So if you double click this, it will open it in VS Code. So this is the code, view, and then word wrap. Okay, to run this script, we need to click on this run. Okay, so if you run that, it will use the Streamlit environment. In the Streamlit folder, I already installed Streamlit and all the necessary packages. I didn't run it, but let me run it against CD. So if you remember, the folder is here, right? Here is the folder, so we can copy this path, and then we need to put it in quotation, Control V. To run the type Streamlit, and then run, and then the Python file, this one. So if I click enter, okay, yeah, it's opening the web app. This is a web app. Let's put it side by side so that we can explain the code. Okay, I'm just putting side by side to explain the code. This is the URL. You can use this URL to open it. At this stage, we don't need this one. We already opened it over here, so I need to close this one so that I can get enough space to explain the code and what it does. So this is the usual thing. I need to import this pandas, matplotlib, seaborn, right? So we also need to import pickle. These are the RDKit packages. We need to import them. To convert this into a web app, we need to use this Streamlit. This is the most important library. The others are commonly used in even Jupyter Notebook. Okay, so we need to load the model and the standard scalar. That's why we used this. The other thing, if you remember, we used 200 molecular descriptors for the training set, so we'll use the same descriptors for the test set. That's why I just put them over here. This is the title of the web app, so you can see it over here. Now we need to go to the sidebar. This contains a sidebar and the main page, so let me display the sidebar. The sidebar is this one. So in the sidebar, we have used this sidebar for solubility prediction. You see this text, there's a formatting here. This is a CSS style. I use this CSS style to make it more beautiful. Let me close this one. There is a markdown in the Streamlit, this part. This text is this one, right? You have another text which is explaining what solubility is. This can be written using Streamlit markdown. Okay, there is a function here to plot the experimental and predictor values of the test set for the 98 compounds. This function, if you remember, we use this function to generate molecular descriptors for molecules, so we need to use that function here too, because we need the 200 molecular descriptors for the test set. Because of this reason, we need to use the function, this function that we used it for the training set. This part, this function can generate a CSV file for the output file. That output file will be a link so that the user can download that file. Now let's see the sidebar. For the sidebar, the user needs to provide smile strings. There is a text box here, so the user can provide one or few smiles using this text box that is indicated over here. Okay, that is already here, this one in the text part. And there is also a sidebar which says upload files. This part, this is a markdown which is already here. The user can also upload files. In that case, there is a file uploader for many smiles. This is the second input, so you can drag and drop the files over here. Generally, for few smiles you can use this text box, but for many smiles you need to upload them using this file uploader. There is also a button over here, so that button needs to be clicked, especially once the file is dropped over here to predict the solubilities. There is a button over here. That button is this part. Okay, here is the text of the button, and the actual button is assigned to a variable prediction. There are three logics that needs to be implemented here: if, else, if, and else. There are three possibilities here. In the first case, the user may enter one or more smiles in this text box. In that case, it will execute the if condition. If the user enters, say for instance, one smile, it will put that smile into a data frame using a pandas data frame, and then it will calculate the molecular descriptors. It will put that into a data frame for the test set. It will use all the 200 molecular descriptors. If there are any extra, it does not include them, so it will use only the 200 molecular descriptors that were used for the training set. The next step is scaling the values. Okay, these 200 molecular descriptors, and it will assign to the X test scale. Then the model will use this X test scale to predict the log S values, the solubility of the compound. It will put that into a data frame. So this is a predictor value, and then this predictor value will be concatenated with the smile strings here. Finally, it will display the value on the web page in table form. Lastly, it will give a CSV file as an attachment so that the user can download it. If the file is dropped over here, pretty much similar to this one, but the only thing here is there are many molecules here. So if the user drops many smiles to this area, it will execute this the if condition. If the user didn't do anything, what will happen? It will just execute the else one. So let me close this part. It will display this part, which means it gives information about the model. It also gives you the limitation of the model. The model only predicts for compounds that have solubility values between -7.5 and 1.7. So this is how the web app is implemented. So it is working. Let's see. If I put CC, just I change it to this one, what will happen? It will execute the if condition. Alright, it concatenated the smiles together with the solubility values and displayed it on this page, right? And also there's a download link, so you can download this one. The other thing is we can upload smiles. Let's drop test set over here in this area. It's uploaded it. So if I click on predict log S values, Yes, it calculated the solubility values and displayed them on this page. There is also a download link here. The user can download this data and analyze it later. This is how it works. So in the next part, we'll upload these files to GitHub, and from GitHub we'll deploy the model to the Streamlit community cloud. That's the next step. How do we upload these files into GitHub? The first thing is we need to generate this requirement. Let me show you how to generate this. I have to open Anaconda. Let's see the path. We need to go to this path. We need to copy this path, and then we have to use cd. Cd means just change directory, cd, and then we need to put it in quotation. Okay, we need to move there directories. Yeah, so these are the files. So we are on this folder. The first thing is I need to remove this one just to make sure we started it new. So to generate that requirements file, we can use pip regs requirements. So if you use this, you can generate that text file. So watch on what's happening here. So we have only 4 files. So if I click enter, it will generate that text file which contains the requirements. Yeah, so if you look at this, that text file is generated, even it gives you information over here. How do you install that? You can install it using pip install pip regs. So if you install that one, you can use this one to generate that text file, which is contains the requirement files. People also use pip freeze. That one is really not convenient to be generated. This is more convenient, but it has some problem. You can fix that one easily. So I noticed that there are 2 already kit files here, so we don't need this one. So I can delete this part. And also we need light GBM, which is not in this part. Light GBM should be included here, so I need to include that one. Control. So these are the requirements needed to run the web app. So I will save it. To save it, just I can use Control S. Okay, now it is saved. So the next part is we need to upload these files into a GitHub repository. So how do you do that? First you need to go to your GitHub account, and then you need to create a new repository. I will give this repository name water solubility. Let me see. Okay, water solubility web app 2, and then can make it public or private. For the time being, let's make it public. Create the repository. Just create the repository. After that, you can use this command just to push your files into GitHub. I have git bash. Let me use that git bash to write the code. So the first thing is you need to go to this folder. So to go to this folder, what I can do is I can copy this path, cd, and then put it in quotation. Okay, how to use paste. Right, we are on this folder. So let's see how the files ls can use Linux commands here. So these are the files: the model, the pickle file, the requirements file, the standard scalar. We have to use git init. Okay, next step is git add. Need to add them. Next step is git commit, and this is first commit. You can say first commit. Let me make it a little bigger to see it. Then we need to use git branch, and then we have to use a remote repository. Okay, copy and paste it over here, and then enter, and finally we need to push it to the repository. Yes, pushing it. Let's see the file on the GitHub. So this is what I have on GitHub. This is the folder. So if you go to this folder, we have all these files. The next thing is we need to deploy this web app into the Streamlit web cloud. You need to have an account in Streamlit, so I have an account already, so I can sign in. You need to select the repository, so the repository is this one. It is main, that's right, but the file is water solubility, so we need to replace this one with our actual file. So this is the file, and the next thing is just very simple, just click on deploy. That is it, very simple. So Streamlit is very easy to deploy your web app. So you can take a look at what's going on here by clicking this. Okay, you can see the progress. So once it is done, you can test it, and you can use this URL to share to anyone who can have internet access so that they can test it. So we need to wait some time. Yep, it's now deployed. Okay, so it's done. Let's test it. Let's change this smile by just adding one carbon. Yep, it is working. Let's test it with many smiles using CSV file. I can drag and drop it over here. Oh, first I need to restart the app. Okay, so I need to drag and drop this to this area. It's uploading now. I can click on predict log s values just to make sure it is working. Yep, it's working. So these are the smiles, log s values here, the solubility values, and there's also a file to be downloaded here, so anyone can download this one. Okay, you can download and analyze the results later. Yeah, that's it. I hope this will help you to solve similar chemistry problems. If you like this kind of videos, please subscribe the channel. Thank you, and I'll see you with another video.